In this video, I will show you how to calculate the volume of a variety of shapes such as these. But first, we need to get our vocabulary down. So, shape A is a prism, all right? A prism has two congruent bases that are connected by their edges. So we know this is a prism. All right, on the other hand, this is none of these. All right, it's not a prism because the bases are not congruent. It does not have two congruent bases, and it's just none of these things. Same with this. This is none of the above. Okay, this is not a hemisphere, all right, because it's missing the little top part is shaved off. Okay, so that's none of these. This is a pyramid. All right, a pyramid has one base and an apex. Okay, so a pyramid has, see, this is the one base, and all of the edges are connected up to this apex. So that's a pyramid. Anyway, let's go ahead and talk volume. Okay, so let's write the formula for the volume of a prism or cylinder. The volume is the area of the base times the height. And just make a note to yourself that this B stands for area of the base. Okay, that's what this B value is. It's the area of the base. And of course, this is the height. All right, so similarly, the volume of a pyramid or a cone is going to be 1/3 the area of the base times the height. And then the volume of a sphere is 4/3 pi times the radius cubed. So these are the volume formulas that we're going to be using. So problem B is clearly a cylinder. So we're going to use the formula that says area of the base times the height. So first we need to find the area of the base. So the base is this circle. So the area of a circle is pi r squared. So that means that the area of the base is going to be pi 3 squared. So the area of the base is 9 pi. So I'm going to take that and put it right there. So then the volume is going to become 9 pi times the height, which is 8. All right, so that is going to be 72 pi. That is 226.19. All right, and the units of volume are always cubed. So this will be cubic meters, or you could say meters cubed. So moving on to part C. This is a pyramid. So the formula for the volume of a pyramid is 1/3 the area of the base times the height. So let's start by finding the area of the base. The base is this rectangle. So the area of a rectangle is base times height. So that's just going to be 25 times 36. All right, that's the area of this rectangle. So the area of the base is 900. So I can take that and put it right there. So the volume is going to be 1/3 900 times the height. The height is the perpendicular distance from the base to the apex, and that is 48. Yeah, I'll just put the whole thing. Obviously, 1/3 of 900 is 300, so I could just type 300 times 48. But most of you probably wouldn't have noticed that. So, excuse me, so I'll just put 1/3 times 900 times 48. So, 14,400. And this is volume, so that'll be cubic feet. All right, part D is another pyramid. So once again, the formula for the volume of a pyramid is 1/3 area of the base times the height. So the first thing we need to do is calculate the area of the base. The base is this triangle that they kindly shaded for us. So we need to find the area of this. The area of a triangle is 1/2 base times height. All right, the base of this triangle is 7. The height of the triangle is not given to us. All right, oh, here it is over here. Phew. I was like, how am I going to get that thing? Yeah, this height right here is given off to the side. Okay, but the height is 9. Okay, so let's see what that is. It's going to be some decimal. That's 63 over 2. And you know what? I'm just going to leave it that way. 63 halves. So that's B. So I can now take this B value and substitute it in right here. So that's going to give me a volume of 1/3 63 over 2 times the height. Now this is the height of the pyramid, and that is right here, it is 5. So this will give us the volume. Let's see, can I slide this over? Yes, I can. So that's going to be 1/3 63 over 2 times 5. All right, 1/3 area of the base times height. So that's 105 over 2, also known as 52.5. And since we're talking volume, the units will be feet cubed, or you can say cubic feet. Okay, what about part E? Part E is a prism. It has the two congruent bases. So the formula for the volume of a prism is area of the base times the height. There is no 1/3 or 4/3 or anything like that. That's a common mistake I've seen ever since we learned about pyramids and cones. Then I see students wanting to stick a 1/3 in with prisms. Nope. So we need the area of the base to be able to do this. So is this the same picture as before? Yay! Yay! We already have this base from the previous problem. All right, it was a triangle, 1/2 base times height. That was 1/2 7 times 9. They came out to be 63 over 2. So we already know that the area of the base is 63 over 2. So we can go ahead and substitute that in. So the volume is 63 over 2 times the height. The height of this prism is 5. Okay, so whatever this is. That's 315 over 2, also known as 157.5. Okay, cubic feet. Part F, this is a cone, and the formula for the volume of a cone is the same as the formula for the volume of a pyramid, which is 1/3 area of the base times the height. So let's find the area of the base. Well, the base is a circle, so the area of a circle is pi r squared. Should I put the r? No, it's pi r squared. So the radius is 6.2, so that's pi 6.2 squared. Okay, look, with that decimal there, I know I'm going to get a decimal if I put this in my calculator. So, I mean, look, if you put this in your calculator, okay, pi 6.2 squared, that's going to give me this. All right, so I'm tempted to round it, so 120.76. Okay, but I just rounded, and it's not the end of the problem. I don't like to round unless it's the last step that I do. So, so that's why I'm not going to do this. Instead, I'm going to take this and plug it in, just so I don't round. Now, if this confuses you, like, look, you could probably plug in 120.76, and you might get, your answer might be close enough that you don't lose any points. But you might lose a half a point for a rounding error. Okay, so you can do that at your own risk. But the most accurate thing to do is just to go ahead and put in pi 6.2 squared. Okay, just put in the whole thing, pi r squared. So we have 1/3 area of the base times the height, and the height is 6.8. And then I can just put all this in my calculator. So now I have not done any rounding, so I know it's going to be good. So let's see, 1/3 pi 6.2 squared, and then that was times 6.8. So that's 273.73. And this is volume, so I'm going to put cubic meters. Out of curiosity, let's see how close it would be if I substituted 120.76. Okay? So, yeah, see how it would be off by just a little bit? So, if you did this, you would have gotten 273.72 when you're supposed to get 273.73. So you would have lost a half of a point for rounding error. All right, for part G, we have a hemisphere. Okay, notice that the radius of the base would be 6. All right, keep that in mind. So the formula for the volume of a sphere is 4/3 pi r cubed. All right, that's the formula for the volume of a whole sphere. Now, because this is only half of a sphere, also known as a hemisphere, then we need to take half of all of this. Okay, so that's going to give us, so I'm going to do 1/2 of 4/3 pi 6 cubed. So that is 144 pi. And since this is volume, we should say inches cubed, or cubic inches. That's 452.39. Cubic inches. Now compare that to this problem. This time we are finding the volume of an entire sphere. So using the formula for the volume of a sphere is 4/3 pi r cubed. I don't have to take half of it like I did last time, was a half of a sphere, but this time it's the whole sphere. So I can just do 4/3 pi 9 cubed, just like that. So that's 972 pi cubic meters. Which is 3053.63. Cubic meters. Alright guys, that's going to do it for this video. Go ahead and click here in the red apple to watch the next video. Click in the green apple to subscribe, or click the yellow apple for the full playlist.